Okay, so what is an angle? Angle is the union of two distinct rays that share only one endpoint. So by just looking at this picture, I think you can understand that better. So to make an angle, you need to have one ray with a one endpoint. From the exactly same endpoint, you can create another ray there, right? And the distance between this ray and that ray, you can find, angle there. So the rays here become side, S-I-D-E, because there are two, put S as a plural, two sides of the angle, and the common endpoint B is the vertex of the angle. So when we name this angle, we can call this angle as angle ABC or angle CBA. It's the same thing. Or just shortly, angle B using that vertex. When you're using angle ABC or angle CBA, you can get to know that vertex is always in the middle. Or sometimes we can just name it as angle 1, angle 2, and so on. Okay? What is interior of an angle? Interior of an angle is when you have a straight line, which is 180 degree, the smaller size is interior angle. So then, what could be the exterior angle? I just talked about 180 degree, not 360, right? So this is not the exterior angle. Actually, interior angle is the supplementary part of that interior angle, which means from straight line, if the smaller side is interior angle, the other side is exterior angle. Okay, so from 180 degree, if this angle here of triangle is 30 degrees, the exterior angle has to be 150. So when you add them together, you're gonna get 180. We call these two angles 30 degree and 150 degree as a supplementary angle because the sum of these two angles is 180 degree. Okay, we will talk about that later. Right now, just know that interior angle and exterior angle, the sum of those two is 180 degree. Adjacent angles. Adjacent means they are neighboring. So when you're looking at angle alpha in pink and angle beta in green, is that blue or green? Looks like green to me. They share one side, ray PR, right? When they share one ray without overlapping, we call that these two angles are adjacent. They also share the common vertex. Okay, so here another postulate can be created. It's very similar to line segment addition postulate. If you guys remember, I can come here. So line segment postulate is like this. You have three collinear points, A, B, C. So there is segment AC, right? Segment AC. So the distance of segment AC, we write it as this. This means a distance between point A and C. That is AB plus BC. So there is a point in between A and C, and sum of AB, the distance, plus BC is the same as AC. That is segment addition postulate, right? Similar to that, if you have an angle and there's another angle in between, by using the same vertex and adjacent ray there, we know that, let's put A, B, C, D, the points there, then we have two angle ABC, I'm talking about this angle, plus angle CBD. This one, when you add these two together, that is the same as angle ABD. So angle ABC plus angle CBD is angle ABD, right? Because they share the same vertex and they have adjacent ray that is not overlapping of these two angles. Then sum of these two angles is the same as the big angle there. That is called angle addition postulate. Okay, so yeah, it's very similar to segment addition postulate. So if you are given two angles, angle ABD and angle DBC, you know that ray BD is adjacent ray, so they share this side. Then we can find angle ABC by knowing the angle measure ABD and measure of angle DBC, because it's just the sum of those two. Okay, that is angle addition postulate. Angle measurement. I want you to know how to use the protractor. If you don't know how to protractor, watch for the tutorial to learn how to use it, okay? Because it's very important. So usually we put, actually I can show you here. Here's the, I need to move this around. Okay, so from A and C, you can see the ray AC and vertex is A and there's ray AB. So there's an angle CAB or BAC. And what's the measure of that? Is that 30 or the other way around? Well, some protractor starts from 0 on the right hand side like this one, but some protractor has 0 on this side, 0 dot 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 dot. But we are looking at this one, right? And then you need to start from 0 here and goes like 5, 10, 20, 30. So angle CAB, measure of angle CAB is 30 degrees. If you want to go a little bit more specific about that angle, we can go deeper with minutes and seconds, just like the time. So I'm gonna show you this.
Welcome to this video. In today's video, we'll be looking at the measurement of angles. So we're very familiar with the measurements of angles: 45, 90, 135, 180, and so forth, going right back around to 360 degrees. We use them every day with our measurements. So I have an example here. Using a protractor, which many of you use somewhere in school, what would you say the size of this angle is? It looks to be somewhere between 30 and 40 at a quick glance. If we blew it up a little bit bigger, some might say, oh, it's pretty close to 35. And if we blew it up even more, we can see it's pretty much between 35 and 36. It's approximately 35 and a half, give or take a little bit. Now, on a scale, if we have a measurement of 35 degrees and at the other end 36 degrees, 35.5 is right in the middle. 35.5 is an example of a decimal measurement. Now, we want to look at how we can go from a decimal measurement of angle to a DMS, a degrees, minutes, seconds. So the D stands for degrees and the symbol is still the same, and it measures exactly the same as a decimal angle would when we measure something, say 30 degrees. It still is 30 degrees. But instead of using point something on the end, we're now looking at an alternative way of measuring those partial degrees. So the M stands for minutes. I'll use this 1 dash. So each degree, much like the minutes of a clock, can be divided up into 60 parts called minutes. And then those minutes can be further divided up into 60 smaller parts called seconds. So the S stands for seconds. And the symbol we use is the double dash, degrees, minutes, seconds. So again, the minutes and the seconds are used to express the fractions of a degree. And they go up to 60, much like a clock would have 60 minutes in an hour or 60 seconds in a minute. So let's have a look now at this clock and consider the rotation of a clock as a fraction. We can have a quarter of a rotation, and that is represented in terms of minutes as 15 minutes. We can have a half rotation of a clock face, and that represents 30 or half past when we're thinking of hours. We can have 3/4 of a rotation, that represents 45 minutes. And finally, a full rotation would be considered as 60 minutes, making up the hour. Okay, let's now look at that as a decimal. Again, a quarter rotation. Well, instead of saying a quarter, we could call this 0.25. So a decimal for a quarter is 0.25. So 0.25 of a degree is, in DMS sense, exactly 15 minutes. It's a quarter of a degree. Half the way around, 0.5 is represented by 30 minutes. So half a degree is 30 minutes. 3/4 of a degree would be 0.75. It's represented by 45 minutes. And finally, a full degree would represent 60 minutes. So let's look now at some examples converting decimal angles into degrees, minutes, seconds measurements. So example 1, if we measured an angle at 20 degrees exactly, 20.00 degrees, that would still be just 20 degrees and no minutes. There's no leftover parts, it's exactly 20. 20.25 degrees, that would be 20 degrees and 0.25 is a quarter of a full degree, so that would be 15 minutes from off the clock. 20.5 degrees, that would be 20 degrees because the degrees doesn't change, and the 0.5 of a degree becomes 30 minutes. It's half of the full 60. Example 4, 20.75. 0.75 is 3/4 way around, and that's represented by 45 minutes. So 20 degrees and 45 minutes. There's the simple examples that we can find from off the clock. Let's look at a couple more examples. How about an angle at 30.05 degrees? I don't know how you work out the 05. It's not an easy example. Well, here's the way in which we can do this. That equals 30 degrees and 0.05 of a full 60 minutes. So 0.05 is the decimal of a full 60 minutes gives me 03 minutes. So 0.05 times 60 gives me 03. So 30.05 is the same as 30 degrees and 3 minutes. How about 30.20? It's going to be 30 degrees. Now 0.20 is 0.2 of a full 60, which gives me 12. So that becomes 30 degrees and 12 minutes. Example 7, 30.60, 30 degrees. The 0.6 of the 60 gives me 36 minutes. So that represents 30 degrees and 36 minutes. 30 degrees, 0.8. Now the 0.8 is 0.8 lots of 60 of a full 60. 0.8 of a 60 is 48 minutes. So 30.8 degrees is equal to 30 degrees and 48 minutes. Finally, let's look at some more challenging examples. My final set of examples. How about something as ridiculous as 40.25833 degrees? Let's try this. Well, it's going to be 40, and then I've got 0.5833 left over. I times that by 60, and that comes out to 15.4998. So that gives me 40 degrees, 15.4998 minutes. Now that's still not a nice even number. So let's look at that 0.49988 and times that by 60 to work out what that fraction is of a minute in seconds. So it ends up that 40.25833 degrees is equivalent to 40 degrees, 15 minutes and 30 seconds. Another example, 40.48056. That's 40 degrees with a leftover of 0.48056 times 60 gives me 28.8336 minutes. Now that's 28 minutes with a leftover of 0.8336 times that by 60 gets it back into seconds, and that's approximately 50 seconds. Last two examples, 40.64444. 4444 here, 4 of them. That's going to give me 40 degrees with 0.64444 times 60, which will give me 38.664 minutes. Now that 0.664 minutes can be further multiplied by 60 to get into seconds, and that's nearly 40 seconds. So that would be equivalent to 40 degrees, 38 minutes, and 40 seconds. And our final example is 40.87083 degrees. That's 40 with a leftover of 0.87083 times by 60 gets me 52.248 minutes. Now that decimal of a minute, the 0.2498, if I times that by 60, that will give me the corresponding seconds. So it's very, very close to 15. It comes out to 40 degrees, 52 minutes, and 15 seconds.
Of course, you can go the other way around too. So let's have this example together. There are more examples on the homework problems and the quiz. So please solve the problems. If you don't understand that, I want you to go back to this video and watch the examples that I showed you on the YouTube video clip. If you want to know the address of the link, please let me know. I can share that with you. And he has more going either direction to find the measure of angle in degree, minutes, and seconds, or just degrees using the decimal or fraction. Okay, so let's take a look at this example quickly. Okay, angle measure in degrees, minutes, and seconds, and you are given an angle. Measure of angle AOC is equal to 65 degree 48 minute, and AOB is 47 degree. Actually, I'm going to copy this. Okay, and what you need to find is that. Okay, so let's go back to our Jamboard and copy that there. So measure of angle AOC is 65 degree and 48 minutes, and angle AOB is given, so you can get to know that vertex is O, and A, let's put that as A, O, C is 65 degree. This is 65 degree and 48 minutes. Measure of angle AOB is 47. So B should be here. So we can use angle addition postulate here. So measure of angle AOB is 47 degrees and 36 minutes. But the total is 65 degree and 48 minutes, right? So knowing that ray OB is adjacent, it's the shared ray, and angle AOB and angle BOC are adjacent, we can use angle addition postulate. So how do we find the measure of angle BOC? You can just subtract 47 degree 36 minute from 65 degree and 48 minute, right? So we can do 65 degree 48 minutes minus 47 degrees and 36 minutes. Okay, 48 minus 36 is 12 minutes, and what is this in degrees? You can regroup 10 ones as 10, 1 tenths as 10 ones, so 8 and 1, 18 degree and 12 minutes. So measure of angle BOC here, measure of angle BOC here is 18 degree and 12 minutes, right? Okay, and we have one more problem from the same example. Let me copy that down. No, it's not given here. Okay, so when talking about angle measures, we know 1 degree is 60 minutes, 1 minute is 60 seconds. Okay, so changing from degrees to minutes and minutes to seconds, you can multiplying by 60, but going the other way around, you can divide by 60.